Good morning. Today we're going to be talking about functions, and we'll start with really what is a function. And a function is just a special relation where each input has only one output, or every x value has only one y value. And as we go through here, we're going to explore what that means within looking at a mapping, a graph, a set of ordered pairs. So let's get started. But here we're going to take first a mapping. And a mapping is just where you have your domain or your x values or your inputs always on the left, and the range outputs, y values are always on the right. And the arrow will always go from the input to the output. So here we have our domain, which is the circle containing 3 and 7. And then we have our range, the circle containing 1, 2, and 5. And we're going to examine our input. So we're going to look at 3. 3 is the first input we're going to look at, and we notice that 3 maps to 1. We also notice that 3 maps to 2. Well, we know that in order for something to be a function, every input can only have one output. And here we have 3 that is an input that has 2 different outputs. So since 3 has 2 different outputs, this is not a function. All right? Now, let's look at the mapping on the right. We're going to look at 1 and 1. We're going to look at our domain and range. And then we're going to look at the input of 1, and it maps to 2. The input of 3 maps to 2. And you may be thinking to yourself, well, they're both going to 2, so maybe this is not a function. But remember, when we look for a function, we're looking specifically at the inputs. Are the inputs mapping to 2 different values? We don't care what's going over there on the output side. So this has not violated the rules of being a function yet. We're going to look at 5, and it maps to 7, and 9 maps to 8. So if you look at 1, 3, 5, and 9, they're each only circled once, which means that they only went one place. They didn't go 2 different directions. So since every input has only one output, this is a function. All right, let's look here at a table. In this table on the left, you will notice that we have inputs of 1, 2, 3, and 7. Now, the output for 1 is 6, the output for 2 is 6, the output for 3 is 6, and the output for 7 is 6. Again, we don't care that they all have the same output. What we're looking for is, do our inputs go 2 different places? And we don't have another 1 listed in that column, or another 2, or a 3, or a 7. So they're not going anywhere else. They're not mapping to another number other than 6. So since every input has only one output, this is a function. All right, let's look at the table on the right-hand side. We've got 2 goes to 7, 3 goes to 5, then we have 4 goes to 2, and 4 goes to 3. So if you look right there at those 4s, that 4 is repeated, and it's going 2 different places. It has 2 different output values. That is a violation of being a function. So since the input 4 has 2 different outputs, here 2 and 3, this is not a function. All right, let's look at a set of ordered pairs. Remember, in a set of ordered pairs, the first value in the pair is your input or your x value. So at the set we have on the left-hand side, we have 0 paired with 1, 2 paired with 2, we've got 0 paired with 3, and 4 paired with 5. Well, we called out 0 twice. It's paired with 2 different numbers. There's one input that has 2 different outputs. So 0 has 1 and 3 as outputs. Therefore, this is not a function. All right? If we look on the left-hand side, we have 1 paired with 3, 2 paired with 7, 3 paired with 11, and 4 paired with 15. We have none of our inputs repeated, so they're not being paired with 2 different things. And so each input has only one output, so this is a function. Now, let's look at a graph. Here, we can just choose an x value. So on the left-hand side, we have 2 going to the value that is right above it, but there's also a value below 2 that's on that graph. So that graph has 2 values at 2. It has 2 different values when x equals 2. And that, in and of itself, makes it not a function. Here, those values look like they're about 1.5 and negative 1.5. But it has several places where that occurs. So we know that this is not a function But we also see there that at 3, we have two different values. If we looked at 4, you have a point above 4 and a point below 4 that would be on the graph. So this has many x values or inputs that violate our function rule. Now, look at the graph on the right-hand side. If we look at our first value where x is, it looks like it's -1 there. X is -1, we have a y value of 1. Where x is -2, we have what looks like a y value of 2. Where x is -3, we have a y value of 1 again. And where x is -4, we have a y value of -2. So we don't have any x's that have a value both above and below them. So since every input has only one output, this is a function. All right, you're going to have a sort to do now that will help you look at determining function, not a function. I encourage you to use the notes that you have done here and think about every input having only one output. You must examine the inputs for this. Have a great day.